fundamentally, the only thing I want you guys to really understand about this area of study is how you compare it to discrete. If we recall how we handled discrete probabilities, it was essentially a matter of saying, like let's say we got our heads or tails thing, or our 3 boys, 5 girls, for instance. You would want to find out the probability of either selecting a boy or a girl, and you'd have a certain number of trials. Like let's say we're trying to select 3 individual students. Whether it's with replacement or without replacement changes how you handle that actual calculation. But basically, if you're selecting 3, you would have like your x equals 0, x equals 1, x equals 2, x equals 3. You'd have those integer values to say how many boys or how many girls you selected out of the total of 3 possible selections that you had. All sampling and estimation is doing is converting that to an equivalent fraction, an equivalent proportion. So rather than saying x equals 0, 1, 2, 3, you now have 0 out of 3, 1 out of 3, 2 out of 3, 3 out of 3. That's really all that's changing here. Okay, let's start looking at some of the typical questions you'll come across. A jar contains 4 white, 6 black. 3 balls are sampled at random, this time without replacement, so binomial is not going to be applicable here. Binomial would require with replacement. Find the probability that the proportion of white balls p hat is equal to a third. So fundamentally, p hat is just x on n, right? X is going to be the number of desired outcomes, and n is going to be the number of total possible outcomes. In this case, proportion of white balls means x is going to be the number of white balls that was selected, and n is going to be whatever the sample size was. In this case, it is 3. 3 balls have been sampled. So what you are solving is the probability of p hat being equal to a third, but it is equivalent to if you had just considered it like you would discrete and just say, cool, p hat equaling a third is effectively the same thing as just saying capital X equals 1, right? 1 white ball was selected. Because we've now converted it back to an equivalent discrete probability statement, we're just going to go ahead and use our discrete probability methods, of which there are 2 main ones you can go about for this because it was without replacement. One method of going about it would be using counting methods. You want to find your capital N, total number of possible combinations, and then figure out the number of desirable combinations. You can use your counting methods to achieve that. You can also just count the number of ways you could arrange those outcomes, right? So for 1 white ball and 2 blacks, you could have white first, then 2 blacks. You could have black, white, black. You could have black, black, white. And then all you would do is just, figure out the probabilities of each of those individually.